Binomial expansion. In binomial expansion, you will learn two types of binomial expansion. The first one is n positive integer and the second one is n negative or fraction. What is the difference between these two types of binomial expansion? For n positive integer, it is written in the form of a plus b to the power of n. On the other hand, for n negative or fraction, it is in the form of 1 plus ax to the power of n. In this video, we will discuss binomial expansion for n positive integer. In order to expand a plus b to the power of n, where n is a positive integer, you can use Pascal triangle or binomial expansion. If you were asked to expand a plus b to the power of 20, you will need to multiply a plus b itself for 20 times, meaning a plus b multiplied by a plus b multiplied by a plus b multiplied by a plus b for 20 times. This could take forever. Well, at least quite a while. Is there any easier way to get this expansion? Let's investigate. The power of a plus b to the power of n can be obtained by direct multiplication. When you expand a plus b to the power of n, there are certain patterns that are noticeable. Take a look at the expansions when the values of n range from 0 to 4. When n equals to 0, the expansion for a plus b to the power of 0 is equals to 1. When n equals to 1, the expansion of a plus b to the power of 1 is equals to a plus b. When n equals to 2, the expansion for a plus b all squared equals to a squared plus 2ab plus b squared. When n equals to 3, the expansion of a plus b cubed is a cubed plus 3a squared b plus 3ab squared plus b cubed. And when n equals to 4, the expansion for a plus b to the power of 4 is a power 4 plus 4a cubed b plus 6a squared b squared plus 4ab cubed plus b power 4. From this pattern, you will notice that when n equals to 0, the expansion will contain only one term. When n equals to 1, the expansion will contain two terms. When n equals to 2, the expansion will contain 1, 2, 3, 3 terms. When n equals to 3, the expansion will contain 1, 2, 3, 4, 4 terms. When n equals to 4, the expansion will contain 1, 2, 3, 4, 5, 5 terms. In general, if you expand a plus b to the power of n, then the result will contain n plus 1 terms. Now, let's explore how to find the expansion by using Pascal triangle. These are some tips when you expand a plus b power n by using Pascal triangle. A. The expansion of a plus b power n has the following properties as we read from left to right. 1. There are n plus 1 terms. N begins with a power n and ends with b power n. 2. The coefficients of the first two terms are 1 and n. 3. The powers of a decreases by 1 from n to 0 and the powers of b increases by 1 from 0 to n. 4. The sum of the powers of each term is the same as the power of n. B. The coefficients of the expansion can be arranged in a triangular array of numbers called Pascal triangle. C. The coefficients of each row are symmetrical and each row begins and ends with 1. Pascal triangle can be generated by certain pattern. First row start with 1. Second row start and ends with 1. third row start and ends with 1. So, the middle one, you can add 1 plus 1 equals to 2. Fourth row, start with 1 and ends with 1. Next, 1 plus 2 equals to 3. 2 plus 1 equals to 3. Next row, start with 1, ends with 1. Then, 1 plus 3 equals to 4. 3 plus 3 equals to 6. 3 plus 1 equals to 4. Next row, start with 1, ends with 1. 1 plus 4 equals to 5. 4 plus 6 equals to 10. 6 plus 4 equals to 10. 4 plus 1 equals to 5. Next row, start with 1, ends with 1. Then, 1 plus 5 equals to 6. 5 plus 10 equals to 15. 10 plus 10 equals to 20. 10 plus 5 equals to 15. 5 plus 1 equals to 6. So this is your Pascal triangle. Example, the fifth line of Pascal triangle is 1, 5, 10, 10, 5, and 1. These numbers represent the coefficient of each term in the expansion of a plus b to the power of 5, where the expansion is equals to a power 5 plus 5a power 4b plus 10a cubed b squared plus 10a squared b cubed plus 5ab power 4 plus b power 5. From this expansion, you will notice that the power of a is decreasing and the power of b is increasing. Note that Pascal triangle is only helpful in finding the coefficient of the terms in the expansion with small values of n.